Good morning, dear colleagues. I would like to present our work which deals with excitation of self-terminating metal ion lasers with a generator based on a new type of switch, gas discharge switch, which was developed in our laboratory and which we called EPTRO. So let's begin. The most powerful and efficient lasers, self-terminating lasers, are those who operate on atom transitions. Particularly the most efficient and powerful is the copper vapor laser. And other powerful lasers are such as gold and barium vapor lasers. In general, lasers on self-terminating ion transitions hasn't been studied as much as lasers on atom transitions, and the reasons mainly are that they generally has less power, average power, and efficiency. So the best results were achieved with calcium ion vapor laser. So for pumping metal vapor lasers, generally cyclotron with magnetic pulse compression or solid state switches are used. This allows to generate high voltage pulses with about tens of nanoseconds leading edge. But there are some other works where switches with the fast switches were used, and it gave some improvement of the output parameters. So here is a figure from this work, and using of kilotron, it is one more gas causing switch, which is able to operate at rather high frequencies, up to several tens of kilohertz. It is shown that output parameters, mainly average, with the average output power increases in comparison with the case when you use cyclotron as a pumping generator. So in my presentation I will talk about another one, switch. It, as I said, is called electron. It mainly consists from two parts, plasma cathode and the capillary part. There could be different designs. In our work we used a planar design, which is illustrated here. So some more information about this switch. We use two additional grid electrodes in order to pre-ionize the cathode region. As you can see from this plot, that initial losses are decreased when you use additional pre-ionization. So it is the main reason of this additional electrodes to use. Here is typical electrical circuits and the waveforms, the voltage on the switch and the current through the load. And one more, this switch has additional external shield, metal external shield around the capillary in order to improve frequency characteristics. This was shown in this work for capillary with circular cross-section. Okay, let's move to the laser part. The studies were carried out with following ions, so it is barium ion, calcium ion, and some additional results with mercury ion. First, we will present results of barium ion self-terminating ion laser. We achieved lasing only in this orange line, and additionally we studied in simultaneously we additionally studied lasing in barium atom. Okay. So he also presented always the energy diagram for calcium ion. It could be seen that it has two laser lines. We measured both of these. So here the gas discharge tube is presented. It is rather common construction with additional external heater in order to control metal pressure independently from the input power from a generator. Here parameters you can see. Here are the waveforms for a barium ion vapor laser. The duration of the lasing was about 5-7 nanoseconds on the base. So experiments were carried out in burst operation mode with frequency in the burst up to 70 kHz. Here are the evolution. Here is presented the evolution of laser energy pulses. So each point is 1 pulse. You can see that for different cases, for different frequencies or voltages, the time that it takes to reach weather energy for it, is almost the same. And all further experiments, all further measurements were done in the steady state mode when weather when weather energy doesn't change for further pulses. So here are two additional figures with evolution. It is useful to say that the time that takes waving to reach steady states mainly depends on the pressure of a buffer gas, which was helium in our case. So here are the measured output parameters in steady state mode. You can see, and two more experiments with barium ion laser. In the first one, we directly compared two different excitation circuits. One was with the first one was with cyclotron and further magnetic compression, and it allowed us to have leading edge of the voltage on the working on the operating capacitance about 30 nanometers or nanoseconds. Sorry. And in the second case, we used our new switch, and it allowed to increase pressure on the gas discharge tube in about 1 or 2 nanoseconds. So here you can see that results with with the application of our switch are much better than in case of conventional circuit. The second figure demonstrates that when you add some hydrogen admixture to the working media, you achieve better output characteristics. So in general, we achieved 125 milliwatts in steady state mode for barium ion laser. Now some results about the calcium ion laser. You can see that duration of the latent pulse is longer than in case of barium. So, and in general, overall output parameters were better. Here, dependence of average output power in steady state mode from frequency presented. You can see that we can that even our switch isn't enough to reach the best results for calcium ion self-terminated laser. It is better to use frequency more than 100 kilohertz. And here, to more dependence, the best results that we achieved is demonstrated here. So for 90 kilohertz, we gained more than 5 watts in a steady state mode. So let's compare our results with some other works. There are only few works, mainly for barium laser. There is only one work where at least peak power was measured, and so in our work we achieved higher results and at least measured the output average power. And for calcium laser, I said in the beginning that for this laser the best results were achieved for all metal wave ion lasers. So the best results previously were achieved in this work, and in our case we have average output power much higher. So if you calculate average power per volume, our results will be an order of magnitude higher. Some short preliminary results concerning mercury vapor laser. One of the advantages of mercury vapor laser, there are few of them, but one is that their level diagram is almost it is similar to kappa atom diagram, and that's why we hope it could give rather good results for this laser. Another advantage is the length, the wavelength. It lays in near ultraviolet. So, as you can see, in general, for this laser we need even higher pulse repetition frequencies. So we are now working on improving our switch in order to reach best output parameters this way. So here are conclusions. Briefly, I can say that we achieved the record values in steady state mode for all self-terminated ion lasers. We demonstrated that hydrogen admixtures improves output characteristics. It was made for the first time. And also we achieved laser non-mercury ion laser transition. Thank you for your attention.